Hi everyone, we are going to take class notes today, reviewing for second semester. So this week we're just focusing on reviewing everything we've accomplished third and fourth quarter. So starting in chapter 7, we solve systems, and when you solve a system, you're looking for where do they intersect, right? Or what is the point that they share? What point makes both of these equations true at the same time? So we can do it with, I said intersection, right? But that would be graphing. And so because it's substitution, we need to think of the algebraic way to solve these. Again, that would be to find, your goal is to find the point, the ordered pair that makes these two equations equal, that make these equations equal. So when you plug in the x and y value, you do the math, you get 21. You plug in the xy value, you do the math, you get 7. Okay, so remember, substitution is all about getting one of the letters alone, was our step 1. And then I always said, find the easiest. Make it as easy as you can for yourself. Nobody really wants to work with fractions. Therefore, we're looking for a coefficient of 1. No 1 there, no 1 there, not there. And here I can see that this is a 1y. So for me, I think the easiest letter to get alone is this y. I do that by adding over the 2x. Not like with the 7, so I'm putting it next to it. I get y equals 2x plus 7. Substitution. We got the y alone, we circle it. We go to the other equation and we sub in, right? Substitution, that's why it's called this. So whatever letter we get alone, we sub in your other equation. So everything else in these equations stays the same. Negative 7x plus 3, our big set of parentheses, equal to 21. In the big set of parentheses, we're changing the y to this expression, which is 2x plus 7. We distribute, bring the negative 7x down. Those are not like. Order of operations says that you cannot do that. You have to do the multiplication first. When we multiply, we get 6x and a positive 21. And so negative 7x plus 6x, I recognize these are like. When I combine them, I get negative 1x. I bring down the plus 21 and the equal 21. And then I'm just trying to get this x alone, so I'm going to subtract over the 21. And I see negative x equals 0. And I can divide the negative 1 to also see that x equals 0. So the first part of my answer is 0 because in an ordered pair, alphabetically, x, y. Now I need to find my y value, and this is where you can go to either of the equations, really. You can go anywhere in the system to find the y, but I always like to go back to my step 1 where I got the y alone. If the y is alone, I can plug in, keep everything else the same, change the x to a 0, and just do the math on the one side and keep the y on the other side. 2 times 0, 0, 0 plus 7, y equals 7. So my ordered pair answer is 0, 7. 8.1 through 8.3. In chapter 8, we worked with our exponents. So in 8.1, we learned when to add exponents. 8.2, we learned about multiplying exponents. I think we also did that in 8.1. In 8.2, we really started to talk about negative exponents, and anything to the 0 power is 1. In 8.3, we learned we could subtract exponents, so reviewing that piece. So the first thing I always said is if you see parentheses in your problem, then take your exponent outside, put in all your invisible ones, take the exponent outside, and multiply it with your exponents inside. So I'm going to bring down y to the first and x to the negative 1, and I'm going to multiply these exponents. I'm going to get x to the 0 and y to the 0, because 0 times 1 is 0. 0 times negative 1 is 0. 0 times any number is 0. So some of us know that, oh, we can just, the shortcut is we can cross that out because anything to the 0 becomes a 1. So this becomes a 1 and this becomes a 1. Those can go away, and now I just need to focus on these. These don't have the same base, so I can't add my exponents. And so I'm ready to make my fraction and stay or move. Ask yourself, stay or move, stay or move. Positive exponents can stay. Negative exponents need to move. When you move, the exponent changes. The sign of the exponent changes. It becomes positive. So my final answer for number 4 is y over x. Number 6, we're moving into chapter 10, which was all about our polynomials. We did operations with polynomials. Remember, operations means add, subtract, multiply, and then divide. We actually didn't divide them, but add, subtract, multiply is what we did operation-wise, and then we did some factoring and some solving. Okay, so to subtract, it says in 10.1, this number we need to subtract. Hopefully you agree that we have subtraction going on here. First polynomial comes down. We just have to make sure we subtract the 4x squared, that we subtract the 6x, and that we subtract the negative 4x cubed. So bringing down 1 minus 2x cubed minus 2x squared. Again, subtracting the 4x squared, subtracting the 6x, and subtracting the negative 4x cubed. So subtracting a negative, that part is going to become a positive. And then it's just all about combining like terms. I don't have any multiplication going on here. I have all addition and subtraction. So it's about putting the like terms together. Like terms, remember, have the same letter and the same exponent. We've even done that in first semester material as well. Biggest exponent I see is 3. These two have a 3, an exponent of 3. So I look at the numbers in front. Negative 2 plus 4, different sign, subtract, keep the sign of the bigger. You get 2x cubed. Now for my quadratic terms, these both have an exponent of 2. That tells me they're quadratic. Negative 2's in front and negative 4's in front. Same sides, add and keep. I get negative 6x squared. Then for linear, this is the only one that has an x, so we just bring it down. And for constant, this is the only one that doesn't have a variable at all, so we just bring that down. Don't forget the sign in front is positive, so we do want to show that as a +1. And then that's our final answer. So we just subtracted those polynomials. Addition is the same way, you just don't have to do the subtraction piece. You just bring everything down and combine your like terms. Multiplying in 10.2, so here's another operations in 10.2. We use the distributive property. How do I know I need to multiply? Well, you look in between the two sets of parentheses. You don't see anything that would tell you multiplication dot. So remember, I need to take the 6x and distribute it to everything that's over here. And I need to take the negative 2 and distribute it to everything that's over here. So 6x times 3x squared gives me 18. Be careful. This is a 1 and there's 2 here. So that's a total of 3 x's. So 18x cubed. 6x times negative 8x, well, that's a negative 48. And then there's an x here and an x here, which means I have 2 of them. And then 6x times a negative 8 is going to be a negative 48x. Now I'm going to take negative 2 and distribute it to all of these. So negative 2 times 3x squared is a negative 6x squared. Negative 2 times a negative 8x is a positive 16x. Negative 2 times a negative 8 is a positive 16. Negative times a negative becomes a positive. After the multiplying, you do exactly what we did in that last one. You look for like terms and you put them together. So the biggest exponent I see is a 3. This is the only term that has a 3. 18x cubed comes down. Quadratic terms, put these together by adding because they have same signs, and you get 54, negative 54x squared. Put the linear terms together. I need to subtract those and keep the sign of the bigger, and I get, and again, you can even just show it off to the side. You get 32, and keep the sign of the bigger, negative 32x. And then my constant, it's the only one, we bring down the plus 16. All right, that's some review from actually 7, 8, and 10 today. Chapter 7, 8, and 10. Have a great day, everyone.